morning once again, our viewers. Uh, if you remember the other time we met on this platform, we discussed the calculation of relative molecular mass and percentage composition with the good foundation of formula of different compounds. Today we are going to look at atomic structure. And we have some concepts we are going to be discussing under the atomic structure. And the first one is the concept of an atom. And what is an atom? An atom is the smallest particle of an element or a compound which take part in chemical reaction. Atom is the smallest particle of an element or a compound which can take part in chemical reaction. And molecule, on the other hand, is the smallest particle of an element or a compound which is capable of independent or free existence. So in some exams, you might be asked to distinguish between the two concepts. It is common in many exams where they say distinguish between an atom and a molecule. So with this definition on the board, you should be able to do that. So an atom, we have some examples of atom like hydrogen atom, and oxygen atom, chlorine atom. Then hydrogen molecule on the other hand will have two atoms of that hydrogen. Hydrogen molecule is two atoms of the hydrogen. Is that okay? Oxygen atom is O. As oxygen molecule is O2. I will have an extended molecule of oxygen which is O3, which we call ozone. Ozone, O3, ozone. Then we have chlorine atom, Cl, chlorine molecule, Cl2. So, there's another concept called atomicity. What is an atomicity? Atomicity of an element or a compound is the number of atoms present in any of them. Number of atoms present in any of them. Either we are talking about the element or the compound. And we have some example on the board. We have hydrogen atom, because it is just ordinary H, the atomicity is 1, just 1. Oxygen atom, because it is ordinary O, the atomicity is also 1. Hydrogen molecule or gas, because it is H2, the atomicity is 2, because we said it is the number of atoms present in any of the element or compound. Oxygen gas or molecule is O2, so the atomicity is 2. Ozone is O3, the atomicity is 3. Sodium metal, as a metal, is the atomicity is 1. So we still have others which can be tested at any point in time in any exam. Like you have to find the atomicity of water. If you have to find the atomicity of water, definitely the first thing for you to do is to be able to write the correct formula of water. We are still doing this based on the ability to write the correct formula of any compound. From our previous experience, we know that the formula of water is H2O. So what number of atoms do you have here? Hydrogen, we have 2 number of atoms. Oxygen, we have 1. So the total number of atoms is 3. Therefore, atomicity is 3. That is atomicity of water. Sand is another compound. You have to find the atomicity of sand. The first thing to do is to be able to write the correct formula for sand. And sand is what? Silicon oxide. SiO2. Silicon oxide. So in that, you have silicon to have 1 atom. Oxygen has 2 atoms. So therefore, when you add everything together, atomicity of silicon oxide, which represents sand, is also 3. Then, if you have to find the atomicity of, let's say, aluminium chloride or aluminium oxide, The first thing is for us to be able to write the correct formula for aluminum oxide. Aluminum oxide is what? Al2O3. Al2O3. So with that, you know that the number of atoms in aluminum is 2. Oxygen is what? 3. The total is 5. So atomicity of aluminum oxide is equal to 5. So then we have other example we can also explore, talking about bigger compound like iron 2 or iron 3 tetraoxosulfate 6. So if you have to find the atomicity of iron 3 tetraoxosulfate 6, you must first of all know that the formula for iron 2 tetraoxosulfate 6 is Fe2SO4 Fe2SO4. So from the breakdown, we discovered that iron, the number of atoms in iron is 2. Then when you open the bracket, the number of atoms in sulfur will be 3, while the number of atoms in oxygen will be 3 times 4, 12. Then when we add everything together, the atomicity of the compound will be 12 plus 3, which is 15, then close to 17. Thank you very much.